All right, so let's talk about increasing and decreasing. This is kind of like if you think of a roller coaster ride and you have a function, think of the little cart. It's going up here, then it comes, and it's kind of constant for a moment, then it goes down, constant for a moment, goes up. So this is increasing, this is decreasing, increasing, decreasing, increasing, okay? And it could be constant, so it could come a point where it's constant for a certain amount of time. Now, notice the word increasing is talking about your Y values, right? Your output. Decreasing, talking about your output. Increasing, talking about your output. So again, what we want here is an interval notation. We want your X values because the word increasing or decreasing, it is describing your Y, okay? So let's think about where we're at. Okay, so on the X, so again, remember it's kind of like domain. You're going left to right, okay, left to right. So on this function, if I start over here, my X values are negative infinity, right? Because if this, this guy goes forever, so I'm at, there's some negative X value down here where it goes down, right? So this part, so if you think of your roller coaster right here, it's starting at negative infinity, right? And then it's coming up. And again, we only care about the X values. The Y values are talking about the increasing or decreasing. So the word increasing is talking about the Y values. When does it happen? From negative infinity to what? 1? Now, this is where I don't know what Newton does. I like using a parenthesis because I don't think you can really land there. Like, I think when you get here, you're neutral, so it's not included. I've seen some textbook where they use brackets. I've seen other textbooks where they use parentheses. So yeah, you just got to see what Newton wants. Okay. On a test, I would accept either. Okay. I prefer probably a parenthesis, but I do not know what Newton does. And I have taught out of textbooks that do both. So math people don't all agree on that. Union, because we're, going to pick up later. Okay. So this is increasing. Let's go to decreasing now. Okay. So I'm kind of jumping over here. Decreasing. All right. So here's my cart on my roller coaster. And notice it is decreasing here. All right, from what values? Well, okay, it's going down. The function's going down from, again, I only care about the X values, 1 to 4. Okay, that's when it's going down. All right, then over here, it's increasing again. It's going up. The function's going up. All right, and so what is that? That's from, where is this point here? We're at 4, 2. So again, we only care about the X values, 4 off 2, and again, you positive infinity there. Okay, so increasing is on these two intervals, right? It's increasing here, then it's going down, then it's going up. So you can kind of see increasing from there to there, then decreasing, and then back up. But notice again, I'm only using the X values, all right? X values. So if we go back a page and look at this graph of the square root function, it was increasing. Again, don't pay attention to your Y values, from 0 to infinity, okay? Because it's increasing the entire time from there to there. And again, bracket, you decide. Or I guess Newton decides, you don't get to decide. All right, let's talk about, say, how we kind of write the notation. So again, remember, this is our function notation. And the reason we like this notation is if I tell you that Y equals 9, you're like, great, what did X equal? You don't know what the X equals. Maybe the X was 1, maybe the X was 2, maybe the X was 3. You have no idea, right? But in math, I could say something like f of 3 equals 9, and then you're like, oh, the input was 3, you shoved it into the f function, and you get a 9, okay? And if you're like, well, why do we use f? Well, there might be another function like g. So say I give you g of 3, and maybe that function just adds 5 to it, okay? So it's x plus 5. So your input is 3, take your input, 3 plus 5, and that output would be 8. So here I know you got the 9 by substituting in the 3 into this function. Here I know you got the 8 by subbing the 3 into that function. So this is kind of function notation, all right? So if I give you, and again, you got to be a little careful on functions. Sometimes people think X means X. And if you're like, Julie, of course X means X. Well, not quite. In functions, this X right here stands for the word input, and it can be an ugly, ugly input. And then over here, maybe you have 2x squared plus 7x plus 3. What that really means is you're going to take 2 times your input squared, no matter how ugly it is, times 7 times your input, no matter how ugly it is, plus 3. Okay. Now, if it's just a number, that's okay. Like f of, say, we'll do something easy, 1. So I have 2 times 1 input squared, 7 times 1 plus 3. 1 times 1 is 1. I get 2 plus 7 plus 3. What is that? Is that 12? Okay. But what if my input has algebra in it? So if you're like x plus 7, okay, all of this is your input. So this x is not that x. This x stands for input, all of it. This x stands for input, so does that. So if I give you an input of x plus 7, then you're going to get 2. Input is going to be what? X plus 7 squared plus 7 times your input plus 3. And then you're going to have to multiply this all out to get a pretty answer. Okay, so again, it can be, a little bit some work. Okay, and we'll try to do one in a second here. The other thing is even and odd functions. So an even function, the way you test this, there's kind of 2 different ways. Okay, one is sub in the opposite to see what happens, right? Because you kind of want to see like, well, if I sub in the opposite of x, what do I get? Well, a negative times a negative is a positive. And notice you get the same thing back, okay? So if you sub it in and you get the same thing back, right? That is an even function. And it is going to be symmetrical around the y-axis, okay? So you can graph it and be like, oh, wow, it's symmetry. Like it kind of like a heart has symmetry, right? Like reflection. And again, I'm not very good at drawing this, but it would have symmetry there, okay? An odd function, still going to sub in the opposite because you want to see what happens when you sub in the negative. So I'm going to put that in there. A negative times a negative times a negative is a negative. And notice here it equals opposite, which is great. It's opposite of the original. It's not the same. It's the opposite. So if it's the opposite, notice the word odd, opposite, and the word origin all start with O's, okay? So this one, and again, I'm just going to kind of sketch a graph, and I'm not very good. We could go on Desmos to do these, but this one, do you see how it has symmetry, like rotational symmetry around the origin? That is an odd function, Now, sometimes it's neither. So if you have a function, say 2x squared plus 3x minus 8 or something like that. All right, let's sub in the opposite of x and see what happens. So it's just kind of a little test to see what's going on. Negative times a negative is a positive, x squared. There I get a negative. I'll just write minus 3x. And then what? Minus 8. Okay, so if you look, these are the same. This is the same, but this is different. If I opposite this, I get a negative here, I get a negative there, and a positive there. So it's not the opposite, and it's not identical. So this is neither. It's not going to have symmetry around the y-axis or the x-axis. All right, I am going to pause for a second. I'm going to try to pull Desmos up so we can do something with that quick. All right, I Googled Desmos graphing, and so what I'm going to do is type in one function, so f of x equals x squared, which we just did, and I use the little caret above the 6 with shift to get that. You can also go down to the toolbar over here, there's that. And I'm going to do g of x. Actually, I'm not going to do g of x. I'm going to do some input and output. Okay, so let's think of input and output. If I input 3 squared, I get an output of 9. And I'm going to label it because a point is really input and output on your function. All right, and then let's do another one. Say I input 2 squared, my output will be 4. So my input is the side length of a square, my output is area. All right, and so what I want to do is I want to find the rate of change between these. Rate of change is, it's slope. But notice if I pick a different point, the slope is going to be different because this function, this quadratic, it's not a line. It doesn't have a constant rate of change. But between these 2 points, there would be a rate of change. But if I pick 2 different points, that's going to change, okay? All right, so I'm going to pause again, and we're going to find the rate of change between these 2 points with our function. All right, so our Desmos, we had our pretty graph. This is my sketch. Input, output, input, output. Now, a lot of you learned the formula y2 minus y1